Hello, everyone. I'm Raj. This is Chelsie. Thank you for your time. We have multiple things to cover here, so we'll just get started quickly. This is about Google AI, and then I'm Charaj, and this is the rising star of Google, Chelsie.
The purpose for hiding the second line is so we can learn how to read with less.
That's the projector.
Okay. I want to know.
Yeah, I mean.
Oh, that's part of our demo. We're doing a live demo the whole time.
So you uncovered.
Because we don't need so much space.
Yeah, I think it's the.
Yeah, I said, you know, it's nice to figure it out. Time. Let me see if I can come.
I was about to raise the laptop, but so yeah, Chelsie works in the I'm sorry. We have a Q&A session at the end. So
By design, I'm joking.
yeah, it's on purpose, not the half though. But thank you.
No more questions.
So we'll get into the agenda. Chelsie, you want to just
Yeah.
carry on?
So I'm a customer engineer at Google. I've been at Google for the last 2.5 years, which is incredibly exciting just based on the amount of growth that we've done in the last 3 years, even for Google Cloud. When I started, Google actually moved me to Austin because we didn't have a Google Cloud team in SoCal. And so when I moved back, it was kind of the start of what we had of Google Cloud in the West Coast, and especially, well, not West Coast, because obviously we have the headquarters up in Mountain View, but at least in SoCal. So it's been such an adventure and what a ride. So I was very honored that Raj came in and asked to talk about what Google is doing in AI and ML, which is a lot. So we're going to just keep it a little high level and go through a little bit of the basics and history of Google with AI ML. And then we'll go through some real world use cases because we want to make sure that everybody here can take something back that they learned from here. I don't want a useless session, okay? And we'll do live questions too, so, or commentary. We'll take either. I want to make this interactive. So the fundamentals of how we got to AI and ML, I feel like has really stemmed down to this fundamental question of us asking our brains, how do you work? Because there's some things that children, that humans can do so simply, but we have a really hard time getting machines to do the exact same thing. And I'll kind of show you some nuances of that in a second. Yes, question? Oh, we've already had this discussion. It's okay. The closed captioning was a last-minute ad. I'll get into that a little bit later. But what this is it's actually, I'll just skip right ahead real quick. It's one of our speech-to-text APIs that does natural language processing. So as I'm talking into the mic, our machine learning models are transcribing what I'm saying and putting it up in the screen. So instead of going and showing you another demo, I figured we could just run this the entire time. And that way, if you miss something I said, it is half there, half not there. So bear with us.
UCLA is yet to be a customer. Once they are a customer.
Raj has been wheeling and dealing all morning. I should just hang out with him more. So this is a Google feature. Oh, the half is UCLA.
It's not a bug, it's a feature. She's the contact person.
Exactly, it's a feature, not a bug. We'll get into feature requests too in our ML models. But one of the issues one thing that we've done with computers over time is we've hand-coded them to have logic to be able to learn. And that's not always the easiest or giving us the end result that we want. So if we see here on the right, say we're trying to hand code a logic of a machine robot arm to pick up materials. You know how many rules of logic you'd have to write to be able to pick up a pen versus a block versus a Lego? So how do we actually get to that learning part that we can have machines actually learn and figure out how to pick it up on their own? Because we don't have to teach our children to be able to pick up a Lego or a block or their toys. It's something that they automatically learn and know how to do. I think we might be getting the half screen fixed. So one of the nuances to that, and it sounds pretty simple, is saying if we're going to teach a computer to distinguish if it's a puppy or a muffin. Pretty simple, right, you think? So you could start by coding, look for the eyes, look for the ears, is there hair? And you'd think that you'd be able to distinguish a muffin as small, round in size, and be able to help distinguish it that way. But this is a real issue that Google Photos has actually run into. So you start putting your logic into the model, and this poor little chihuahua is getting classified as a blueberry muffin. Or a muffin, even. We don't have to get to an actual blueberry muffin. But this is one thing that we've really run into. It's something that seems so obvious. I know my 4-year-old niece would be able to pick out the difference between a chihuahua and a blueberry muffin. But how do we teach computers to be able to learn and to distinguish between those? Because when you start describing it, that little chihuahua looks like a blueberry muffin. So think about how we've gone through and we've been able to make some of those assumptions and be able to learn that way. So we have neurons that are firing, and we're able to receive information, classify it, and then send it to other parts of our brain. And we're able to make these connections across our entire brain to learn and to make these classifications. So this is where deep learning really comes into place. If we look at the picture on the left, is it a dog or a cat? Kind of be cognizant about how your mind goes through this. Because at first it looks like a pile of dirty laundry, and then when you get a little bit closer, it's an animal with long hair, and it could honestly almost be distinguishable for a cat or a dog. So every neuron that's firing goes through each layer trying to narrow down what the options are. And so essentially this is what we call a deep neural learning network, and it's created off of the same way that our neurons fire in our brains to be able to classify these images. So if you think about it, it's something so simple like the puppy or muffin, but it can be a little bit more complex when we actually bring this to computer and machine learning models. So I'm not going to actually show this video, but if you have time later, there's a fantastic video of the CEO of DeepMind. Yes, DeepMind. We acquired DeepMind back in 2014, and you know what it did at the time? Anybody? No?
Play Go.
Exactly. Yes, they did. Yes, they played a game, and the founders of Google flew out there and bought it on the spot. Can you imagine how much an investment for just a machine learning model that is able to play Space Invaders? Well, the beautiful thing about that is that it's able to learn, and you see it running on a single GPU. They paid too much? Oh, I have no idea what they paid.
A lot.
A lot, way. I would love to see that money in my bank account. So fast forward 5 years, this was in 2014, we're in 2019. What is something that we've been able to do with that exact same model in our own business? So we've been able to apply machine learning even to our data centers. And we have a lot of data centers and a lot of data in a lot of areas. We've done a $3 billion investment in the last, I guess that was 3 years ago, and we're doubling that for the next 3 years. So when we applied machine learning across our data centers and how to cool it, we were actually able to show a 40% reduction in power that we used. And this is incredible because this is the energy output that we have in the graph when we weren't using the machine learning models versus when we turned it on and it goes down. And then you can kind of toggle it on and off to see what the energy is. So these are things that we can take the base learning model that we had and apply it to huge business problems that we have and actually get results out of them. And honestly, it is the essential same model that was able to go from the Space Invaders game to the cooling, because what they were able to do is just change some of the features, clean the data, and then they were able to have it learn, and they gamified it, so when you have lower energy, you're actually able to, it's like computers, there's actually a PhD research thesis titled "Computers Can't Get High." Anybody know why that would be important to machine learning? No, well, that's kind of part of it. Well, one is that dopamine that you get when you're doing something right is how you learn. And that's how you continuously evolve and learn and try to make the same happenstances to evolve to get there. So this is important to bring that gamification into a...
Just to avoid the machine?
Yes, just to evolve the machine. So you have to program that quote-unquote dopamine into the deep learning models to be able to create a machine learning model. Well, I mean, we only have 45 minutes today. I'll show you some easy ways that we can help you with that. But today, I love this slide because this shows in 2018 there was a survey done of CIOs of how many are deploying AI in their environment. 4%. That's not a lot. Where are we going to be in 2020? 85%, magically, kind of like a machine learning model. You throw it out there and there's this mystical unicorn of magical results that you get. Well, where are we today? Oh man, we don't have that slide. Oh no, we do. It's here. 12%. So how are we supposed to get from 12% as we're closing out 2019, there's only 3 months left of the year, to 85% end of next year? Well, this is really where we have a lot of different tools that are able to help, and we'd like to believe that they'd be able to help. There's a lot of, or very few select people that are able to take an entire model and train it and be able to do feature modeling to create a deep learning or machine learning model. And a lot of the organizations that I work with today across Southern California don't have an entire data science team. And they can't afford to, two, it's hard to find talent. But they do have a lot of BI analysts and also data experts. So data is the most important piece that you can have, and if you don't have good data, then you can't have good machine learning. Whatever goes in the system comes out of the system. You guys have all heard variations of that. So Google has been doing AI and ML for a very long time. We have indexed the entire internet, and that's how we got search. And we've really made machine learning and AI into the core of everything that we do. We've integrated into your search ranking results, into Gmail Smart Reply. It's fantastic because I no longer have to type out full emails. Gmail has learned what I want to say. Photo search versus the chihuahua and that poor muffin, or the poor chihuahua and the muffin. We've been able to distinguish between those, and we've tried to integrate it into every single one of the consumer-facing products that we have. With that, like I said, data is the most important part. So we've created ways that using your data, you can use tools to help you create these machine learning models or apply AI to your enterprise without having to sink that great, huge investment into data research or data scientists and machine learning specializations. One of the things that we had to do to be able to come up with some of these innovations is create entirely new hardware to do this. Is everybody familiar with the GPU, a gaming processor unit? So that does a lot of computation and parallel processing. And I love this slide because I used to be a hardware engineer and I used to have to thermocouple up GPUs to be able to test them, and we'd actually play video games to thermally test them. But now TPUs are really focused on doing matrix processing. So it takes it a step further when you have even more data than what you can handle with the GPU. So it's able to crunch absolutely massive amounts of data in shorter amounts of time, which also you can say then brings down your cooling costs because you're not running all the GPUs in a server rack. But there's a couple ways that we can bring TPUs and the whole machine learning models to actual companies that have issues that they want to solve with that. And some of that is actually using the tools that are available or sitting down and creating and training your entire custom model. And this kind of breaks down where we have solutions and tools for everybody. Basically, moral of the story, we have something for everybody. Depends where you are. From being able to do deep learning VMs and just spinning something up to having AutoML, which I'll get into a little bit more deeper. But AutoML is basically the ability to drag and drop to train your machine learning models. So think of the pictures of the Chihuahua or the muffin, and you could click and label them and essentially have a monkey be able to train your data, because, or a 4-year-old could go through and hopefully correctly type what your model is, and that would be able to train and create a model without having to program or test it yourself. So here's kind of the entire suite of things that are at your disposal to use. There's TPUs, which can help crunch massive amounts of data. There's compute engine, which is basically essentially VMs, and we have predisposed images of deep learning to be able to help you run. So it's everything that you would need to just click the button, it starts the VM, and any tools or resources for that you could leverage. We have Dataproc, which is data processing, Kubernetes engine, which is basically anybody familiar with containers, a one-stop shop of being able to control and deploy containers across your entire enterprise. And then the Cloud ML engine, which is basically a mix between using compute engine and being able to just push your model into ML engine and just letting it run. For anybody that's familiar with App Engine or Heroku, it's kind of like that, but for machine learning. And then you have the magic AutoML, which is absolutely incredible. This is where we train the models and you give it the input and guidance to get there. So that's what I was talking about, the graphical interface that you can actually drag and drop to train the models. And then that is your data, but our models. And then the other part is your data and your models, and that's where there's a lot more time that goes into being able to tweak and make these things exactly what you need them to do, and that comes with a lot of expertise from your side. Of course.
So, when it's the AutoML,
Mm-hmm.
what is the transparency of the model? How does the person who's using the data in your guys' model, do you get to see what parts of the algorithm do?
So there are some controls that you get to do, so you get to see what your loss is, what you're trying to converge into, and you can do minor tweaks into that. Typically, it's a little bit more hands-off from the controls that you get to use because you're using our model and it's your data. So there's, think about it as you could tweak and guide it, but you can't control exactly what it's going to do because that's part of the ease in it, of that you can throw your data at it and then be able to train it against our models that we have within Google. So it's kind of the in-between phase of how much control. Correct. You're not actually touching the code. It's all through a user interface that you have, which is kind of nice that you don't have to sit down and program everything. The other part that we have is AI platform, which is an end-to-end platform for basically everything AI. And the nice thing about that is that you can reuse code, you can share it across enterprises, you can share it within your own company. I have some customers that are working with us just to be able to share their models from one team here in Santa Monica to, say, Austria, where they have another data science team. Or they wanted to do video processing, and they've shared the model that they had through other companies that are here in SoCal as well. So it's one way that you can kind of come in and take anything and everything that you need for AI in one spot. And then with APIs, that's where we kind of beat the punchline here with the APIs that are actually translating what I'm saying using natural language processing and then outputting it here at the bottom too. So these are very simple of what you can do to drag and drop and include any programming to be able to give yourself a little bit more customization. So we covered AutoML. And this is when I say a graphical user interface, it's literally drag and drop images that you can label yourself, or you can have the interns on the team be able to label themselves too. So basically everything that I've talked about, there's a few different parts of the AutoML vision. One of my customers was actually the go-to-market for the AutoML video, and where you see that being applicable is when you're saying you're watching YouTube. I'll use this as a generic example, and it gives you what you should watch next. This was for a media company here in SoCal that wanted to be able to give a video recommendation based on what they watched and their preferences without having to build their own models. So it's one way that you can help personalize content for your users without having to have an entire data science team. And this is where the customization comes in. It doesn't have you actually create your entire model. It guides you through defining your schema model, analyzing your input features, and then you can train your model with your feature engineering, but you can guide it through training it. So you're not actually doing the training. And then when you're done, you can evaluate what your model behavior is. I'll show you here. And then actually compare it to other results of hand-tested. And we've seen that using AutoML, because you're using models that we've used internally, that you typically can even get better results than a model that's even created via your own, from the ground up with your own team. So I think I'll pass it over to Raj to talk about how you can bring some of this into your own workplace.
Yeah, so now I'm assuming that everyone knows machine learning.
Or they're asleep, you know.
Yeah, Chelsie is really a good teacher. So, so we'll get to how businesses are using machine learning. These are actual customers across verticals where machine learning is being used today. And while I check, I'm sure there is a mix of audience from different verticals. So how many from retail? Anyone from retail here? Anyone financial services, consulting,
Media.
and media, entertainment?
Oh, there we go.
Wow. Okay. And which one? Healthcare? Tech?
Isn't
Wow.
everybody in tech here?
Wow. So, but
You forgot manufacturing like everybody else does.
yes.
It's up there,
Nice.
front and center.
So the last 10 slides are dedicated to you. So I didn't forget. I thought you would be the one in the room. So I'll just quickly, I wasn't sure. Like today, I thought that I'll pick up something that we've done which applies across an industry, so everyone can relate to. And what I picked was retail. Everyone here loves to shop. You are fantastically dressed, and I'm sure the retailers know everything about you. So I'm sorry?
I said keeping the economy going.
Yeah, thank you. So what I thought was I'll take you through the journey how a retailer today, they almost have to do it because their competition is doing it. The advanced retailers now have, even here we see more and more retailers now having a data science team, not just in IT, but also closely working with marketing. We worked with multiple retailers where they start the journey right from identifying your behavior based on how you interact and how you click on the emails, whether based on season, based on, there's a fall collection and you start clicking on fall collection, suddenly you'll notice your inbox filled with fall collection, not with the same retailer, but across different retailers. Sometimes when you go buy furniture, larger goods like furniture or car, you bought the car, you still have some emails coming in. Same thing with travel, right? These are industries that are on the forefront. They have no option. So I'll cover the journey through marketing and how they go through with sales forecasting, and then operations as well. So, of course, we talked about data, and there is companies have diverse data sets stored in different, almost anywhere from siloed to they correlate in the cloud. Those who are advanced. And this is an interesting concept. I went through this exercise, learned a lot in this engagement. So if I look at this, the first and normal way of, or the first step is actually to take data, which is the transactional data, which is the order data, right? The purchasing data. So we take that, and I'm going from bottom up on the left side. And then we go into pricing, where there is pricing based, you can adjust, retailers adjust pricing based on demand. It is not just the pricing of the individual item, but also based on a lot of other things. How much you buy, how much does the retailer have in stock, or the speed of buying and all that. There's extreme complexity involved in this. And so the next one is holidays. And you retailers, we almost wait now for the big holidays, July 4th and Thanksgiving, where we want to push our purchases right till then and wait for a deal. Now you can compare deals online and then go to the store, pick it up, or if it is free shipping, get it shipped. So our behavior has also changed based on that. So at this point, and then we mapped what were the number of visitors onto a website and took that and correlated that with the visitors who actually went to the store. So if they had my email, then they have a cookie on the website, so they know I visited on the website. I clicked on the email, the campaign, and then I clicked on specific campaign. So let's say it was a leather, a leather launch, a blue color leather launch. It's more like spring, but and then I clicked on that, and then I have a matching sofa, a matching ottoman. So a lot of things are going to come in that way. And then based on my behavior, online behavior, soon there'll be, as soon as I walk into this store, the store is going to, hey Raj, looks like you're interested in these. So how about this? This is the promotion I have. And I, as a consumer, I'm going to be intelligent as well, saying, oh, this is the right time for me to go in and get the best deal. Right? Then, so that I was blending both correlating both my online behavior as well as actually going to the store. The market and of course the marketing campaigns. Now, one interesting thing was we were working with this retailer, which is largely in Southern California and across the West Coast, right up to Texas. Then we started, we got to a model accuracy of 78, and we wanted to go over 80. And the one thing that was remaining was weather. So, and the model was across multiple stores. And what happened was that we actually worked very closely with the Google AI team. Mm-hmm. And then they said, Southern California weather doesn't change. So actually adding one more feature is an overhead for the model. So we had to split it, and we had different models for different stores. And we still got to 85 on some of the stores. But again, you get to a challenge where the new stores didn't have much data. So there is a lot of challenges while we go through these models. It's still early, but those who have data are just forging ahead. So here are some, there's a demo, but for sense of time, I just have snapshots. This is comparing the website analysis of the website, and then what is if it's an existing customer, what is their feedback on the website, the sentiment analysis. It happens live, just like how you see the speech to text.
Half of the speech to text?
Sorry?
Only half of the speech to text.
Yeah. So while you shop, you realize that your recommendations are also based on how you shop. There are some things that in AI, for example, if I'm shopping for Chelsie, I'll get recommendations for myself, but not for Chelsie. So those are things that still have to be solved. There was a question that, hey, if from in my past session that hey, if I'm shopping for my son or daughter, how does AI know that they have to recommend certain things for my daughter or son? I said, no, AI doesn't know that if you're using their login or using your login. Then there is sales forecast, and we'll get to, there's a better slide. So all these are tied together. There's a imagine marketing campaign getting into your behavior, buying behavior, the company is using sales forecast real time, and then going into the inventory, having inventory, supply chain, distribution, all with realistic predictions. So this is the store that I mentioned. The last 3 weeks, if you see, that is the ones in blue is actual prediction, and we the halfway you see a spike in blue, which was the actual. That is when stores started changing their time to for Thanksgiving. They had a holiday on Thanksgiving, so there was pattern, and Thanksgiving is significant for retail. So they had a pattern of a holiday on Thursday, but then stores started to move and open the store on Thursday. So you had Thursday sales, which actually put off the model. So that's why this. But you see, they already know that the number of people expected at the store. There was we also found out stores which are closer to the office have more traffic on Wednesday and Thursday, and then stores, of course, in urban suburb areas, there with residential areas had more traffic over the weekend. So lot of simple complexities that extended our computation. But you see with this intelligent data, you are able to identify how many people can come in, how many people can come to serve the store, what promotions you can have, what kind of people are going to come in, and it's the possibilities are endless. This is about sales. You can see the one that is. Basically it's you have a prediction over. You can have a prediction anywhere from 2 weeks out to 4 weeks out. Generally 2 to 4 weeks is what we found as accurate. At the bottom we also have the propensity to buy. You can go down at the individual user level or the consumer level. You can find related products as well. This is demand sensing. This is manufacturing. This is bread and butter now for manufacturing, where anywhere from companies who have people doing, just throwing in numbers by hand, or just raw math on computing, saying my forecast is going to be 100, 200, 300, whatever over a certain months, versus going to Excel computations. We've come across a company who had one person do forecasts for 22 years, and that's all he does. And then he said, okay, we'll do a model. So he says, what does the model know that I don't know in 22 years? So this is pure data, right?
Raj,
Yeah.
to what extent was a customer's home address or zip code in any of the analysis? Was that factored into any kind of analysis?
Zip code, yes, not the home address, zip code, because you, as a customer, now you see more stores going and asking you for a home store, right? So when you tie your email to the home store, they assume that you are, and you tie the purchasing transactions, then you are largely associated with that store. But that is personal information. It'll be a big deal now, January onwards. So, and then this is about pure end-to-end supply chain, just matching what is computed by your existing team or your existing systems to what is being forecast by your BI system, business intelligence systems, to now machine learning. So this is a company that I mentioned was very interesting. They are retailers here. I'll refrain from using the name of the company, but they are not only do you get insight into what is happening and what will happen, but you're also, it gives you tools where this kind of data gives you tools where you can totally rethink how you are planning your merchandising, how how you want your entire supply chain. So I inserted this. There are 3 slides here, and this is something very fascinating. It's called Document Understanding AI by Google. And what it does is, imagine someone sorting either paper copies or digital copies, and this is a digital equivalent of the person, where they are able to classify the document, they are able to extract the data, and they are able to analyze if the data is accurate or not. I'll give you an example. We're working with a company which has 30 people going through approximately 100,000 documents, and they are into loan processing. And just like, whether you have loans or whether you are renting, then you fill an application. They have a loan application, they have the bank statement, they have salary statements, they have your driver's license, all of these. They come in different forms. And with Document Understanding AI, in fact, Chelsie and I work together on that. With Document Understanding AI, the model is able to predict in a high 90% right now. We're adding more data. We should be able to do it, fully automated, where we are going to identify documents directly where it says, okay, this is an application, it goes to a different folder. This is a license, it goes to a different folder. And then with that, we extract the data. In some cases, so that's the classification. The next one is validation of data. In some cases, some documents have date of birth. The other one has birth date. So we can take the data, we can rationalize that. And this is natural language processing. This is beyond OCR. We take that data, we can feed it back into the system and also identify what pieces of data is missing. So this is, I believe I read last week that financial sector, 200,000 jobs are going to be automated in the next couple of years. So with something like this, I mean, it is absolutely mind-boggling even for us while we, there's a surprise element, but when we start working on it, it's just ridiculous what comes out of it. This is our other great institution, USC, where we are automating clinical trials. And I have this on purpose so that UCLA also engages with Google. So this is a project where there is clinical trials. Imagine it's a text written for about let's say 20 or 30 pages. That is the clinical trial. We extract data from it. We map it to the clinical trial guidelines, and then we get data out in a form of an Excel matrix. And it answers questions on the qualifying trials. And there are 7 questions here. We answered 6 out of 6, and the 7th is we're working on the 7th one. And then this is what the sheet comes out, where it extracts data, put the events together, and identifies which one is research and which one is standard. And again, the big challenge for us here is that when you automate, you have to automate 100%. Otherwise, you have to identify the exception. But if we know the exception, we might as well automate that. So it's still, but we are past the 90% accuracies, pretty close. So very, very interesting. This is the accuracy of different protocols. I just had the slide there. Any questions? I'll go to the last section. So this is a very interesting engagement we worked on, got to learn a lot. This one is with Budweiser Brewery, and I tried to put it into a graphical form where everyone knows the rules of innovation and all that, but we saw this company that really has it in their, they have the mindset, they have the grit, they just wanted to go and think different and do things different, right from start to finish. And so I blended multiple articles, and a lot of this is not my own. Like a true consultant, you take data from somewhere, and then so these are 7 steps in any supply chain, right? And what we did was we identify every single problem within a supply chain and associate that to what is the benefit you can get. Now we are talking of pure ROI, identifying priorities for your innovation. Ranking something like a FICO score or a credit score. This is like an idea score. This is the process, how they went through this. So every single stage was taken. The top. I'll just go through this. Skip through this very quickly. And the top problems, challenges, or opportunities were identified, and they said, how do we use AI? And they came to the Bay Area, and Don, this is very interesting. They came to the Bay Area and they said, okay, we'll pick 14 vendors, and we have 19 initiatives that we want to go after. And the first day is all about them pitching, this is our problem. Right? And the next day is the vendors choose which problems they want to work on, and they come back and they say, this is our solution, or our preliminary idea of how we want to approach this. And then we were lucky to work on 4 of them. We finished 1, and so this goes across, right, from strategic planning to sourcing. Now, sourcing is huge. I told you about the document understanding AI. There are companies now which are able to identify your entire purchasing contract with AI and able to identify what are the flaws. And then based on the requirement, they align resources to that, saying, this is your contract, this is the resource that may map into this, so you can go hire from this company. So it's like a portal where vendors join that platform, and as they get this for large companies, as they get vendor contracts, it automatically recommends which vendors to go to and what profiles would match up to that need. I'm just going through this. So these are, and then you have the solutions. You match the solutions. So there is the problem, there is the benefit, and then there are the solutions. Once you have that, you go in and prioritize. And this happens to be AB InBev, and AB InBev was declared the best innovator in CPG by Gartner to 2019. So we are very excited to work with that. This was, by the way, the specific project was preventive maintenance, and it was identifying when to change the beer filter so that the yield of the beer is much higher, and basically all of us here have better Budweiser beer. So I put this together because not just Google, but there are other. This is typical with any cloud provider or anyone who's offering new service, and I want everyone here to know that to follow these 3 steps. And the first one is, of course, learning. There are all these innovative companies dying to engage with the industry, and these are my numbers, the one at the bottom. So if you take 10%, which is 4 hours a week, and you literally invest that in learning, then there are multiple companies. Of course, it needs to make sense. I don't want you guys to go and pick one vendor every week, but it needs to be relevant for your company, and learn from them, and then come back and start to innovate, because things are very fast. And in fact, day before yesterday, I was listening to one person, and he says, the way we are going, the next person we are going to hire next year is going to be a robot. So things are moving very fast. The next one is the proof of concept. there are again, these are companies, once you have a meaningful project, the companies will invest in you. It will co-create a solution. And there you want to make sure that 80% of what you create is usable and not a fun stuff. I've had a situation where one of the executives in a company was dying to say, you have to do ML for me, please. And there was no data. And then finally he said, I want it on my resume so I can get on to my next role. So he was honest enough and candid to. And then, of course, last one is, this is a standard, right? You want at least 100% would be great, but you want at least 2/3 of what you start with to get benefit in that project. So, yeah, with that, this is Chelsea's office. This is where she works every day.
in San Diego. No.
Oh, yeah, right. But this is the Google office. Some of you have been.
Yeah.
And yeah, any questions? Yes, sir.
So
Did-
in all the use cases that you've dealt with here, right, there's a certain element of subject matter expertise that you depend on the client versus your internal expertise, things like data, right? How do you draw that balance? I mean, are we getting to the point where algorithms and data and all that stuff is getting good enough in terms of prediction that subject matter expertise gets
Overridden?
overridden or less?
No,
attention? So
yeah.
the question is I believe it's the opposite, but I'm going to ask you to counter argue. Because I think things like machine learning and artificial intelligence depend on information in context. But the context is provided by experts, right? Subject matter experts. How do you, in your business, how do you draw that line? Where do you find challenges with clients and things like that?
Yeah, I'll answer the comfortable one first and then answer the ones that are tough for us. The comfortable one is we have practice leads who specialize in supply chain. I used to be heading IT, and I know the document understanding AI. I can do that in my sleep, except I was doing it in OCR. The manufacturing, same thing. We know the process. I've built the system ground up, so I'm lucky on that part. But there are cases where, so I completely agree with you. And it is not finite where there is, it's not mutually exclusive where the customer or those who are interested provide the subject matter expertise and the domain, and we just come in with AI. No, it doesn't work that way. And it is a co-creation. AI generally, forces you to change the way the entire process is. The other one is in marketing. Marketing, we are still learning. We don't have 15 years of experience as being a CMO or a head of marketing. So there we do face difficulty, and we engage with the customer more. We listen a lot from the customer, and we are pretty open about. This is still early. The ones who engage with us are usually the ones who are pretty serious taking this forward, and they are ready to invest time, people, and expertise. I think we are out of time, but we are happy to. Yes, sir.
On the heels of that question, is it fair to say, Raj and Chelsie, that the process really, you require people to validate the models in many cases. You don't rely exclusively on the results of the algorithm or the model, the ML model, so that you have to have people who are subject matter experts that also participate in the decision-making process ultimately. Is that fair?
No, absolutely.
Yeah, it's part of when you do want to do a pilot too. We like to be able to understand what your results are versus what you currently are doing. So that way you can compare the two. And that's part of something when we do an investment into you and co-create something, we'd like to have specific success criteria. And part of that is just understanding exactly where the new model would the accuracy wise compared to what you're currently doing. So there is a level of when you're creating it, you need to double check it. You need to be able to always have that baseline of knowing where you've been to be able to evolve and go further with it. And there will always need to be people to help guide that. The models, or that you can't just throw models at it and everything just magically works. I think that's a lot of the industry buzzwords that we have today, that people think, I have data, I throw it at a machine learning model, and just magically you have a unicorn data set that comes out. So it doesn't work all that way.
And the engagement doesn't end with just the model. We are talking about replacing the model with the existing system or the person who's actually computing the, you know, the manual prediction or the system, or a combination, and replacing that. In our case, the automation that we're talking about with document understanding AI, we're talking about not replacing the 30 people who are doing 100,000 documents, but now the ability to do 1 million documents with the same 30 people. So, so there is a period and where the entire model is tested and compared, whether it is right or wrong.
Is the recognition of the letters typeset, or can you do cursive or printing as well?
Oh, the captioning here?
Yeah. No, not this.
No,
Oh.
the document understanding? No,
Yeah, that's.
do you have, I'm assuming you have very good handwriting.
I'm left-handed.
Yeah. Oh,
Yeah, that's part of the models that they build into, is just being able to detect handwritten and convert that into a text, and then they've kind of gone through all the different scenarios. So it doesn't have to just be typed up. You can scan it in. Some of it can be free form, some of it can be structured. So
now we are working with one where it can understand whether a signature was completed or not. So it can directly go back to the sender. So it's pretty interesting and crazy stuff, which is we cannot avoid. It's just going to hit us. Yes.
The document AI, the data you are extracting from those documents.
Yes.
It's basically.
Well, thank you guys, by the way.
Answer